Okay. This time we're considering a spherical convex mirror with a focal length of 25 centimeters, and as before we're asked the nature, size and location of the image formed by, in this case, a 5 centimeter tall object placed 30 centimeters in front of the mirror. So, as before, we could do this just by applying equations, but let's draw the optical system out so that we know what we're talking about. There's my optic axis. Here is the position of my mirror, and this time I'm going to make it a convex mirror. The radius of curvature, and therefore the center of curvature, and therefore the focal point, are behind the mirror, and therefore by the real is positive they are negative quantities. So the focal length is minus 25 centimeters. Okay, we're asked about an image placed in front of the mirror. It's a little bit further along than the focal distance, and I'm going to exaggerate the height, because if I don't, my ray diagram isn't going to work very well. Okay, so as always, we can consider a ray which is parallel to the axis, and such a ray will pass through the focus, and therefore appear to be coming from behind the mirror. And the other ray, which we always consider, is through one which will pass through the center of the radius of curvature and will therefore be reflected back upon itself. So let's look for that one, and drawing it in. And that ray will be reflected back along its own path, because it will strike the mirror at 90 degrees. So, and therefore it will appear to have originated from behind the mirror. So where the rays cross is where the virtual image is formed, and you can see that the image will be upright and it will be reduced. Now let's do the math. So as before, we can use 1 over p plus 1 over q equals 1 over f, and when we substitute for f we must use minus 25 centimeters. If we do all of our calculations in centimeters, then we're using consistent units and our answers will be in centimeters. So we don't need to change to meters, although if we did, our answer would be in meters. So the first thing we want is the image distance. So 1 over q is equal to 1 over f minus 1 over p. That's subtracting 1 over p from both sides. And remembering to consider the right-hand side as a single unit, if I invert both sides, I get q is equal to 1 over f minus 1 over p. And substituting in, I will find that q is equal to minus 13.6 centimeters, and the minus tells me that it is a virtual image, which we already knew. But nice that the maths confirms it. And we can use the magnification. So the magnification is the image height divided by the object height. So magnification m is equal to image height over object height, and that is equal to, because of the real is positive sign convention, minus Q over P. So the magnification is equal to minus Q is going to be 13.6 divided by P, which is 30 centimeters. Sorry, 13.6 centimeters divided by 30 centimeters, which is equal to 0.453. Therefore, the image is smaller than the object, and the image size is 0.453 of the object size, which is 5, leaving us with, he says, scrabbling for a calculator, that the image height h equals 2.27 centimeters. Okay, so moving to the top right hand side to actually answer the question, the nature, size and location of the image. It is an so-called erect virtual image, or you can use upright instead of erect if you prefer, which is 2.27 centimeters high, formed 13.6 centimeters behind the mirror. And as I've gone all over the place for that answer, as before, please make it clear for the poor person trying to mark where your final answer actually is. And we're done.